Divide with whole numbers and fractions. So whole numbers can be turned into fractions by putting them over 1, which we did this when we were multiplying whole numbers and fractions. But this time we're going to now divide. So let's look over example 1. We have an 18-inch long pipe that needs to be cut into pieces that are 4.5 inches long. How many whole pieces will there be disregarding the curve? So we're going to use the expression to solve. So what we did was we took this mixed number and made it an improper fraction here for us. And now we have 18 divided by 9 over 2. So we have a whole number here of 18. But all we can do to make it a fraction is put it over 1. Then we have this division symbol, but we can change that to multiplication if we go ahead and multiply the second number by the reciprocal. So we have 18 over 1 times now 2 over 9, and now we can go ahead and solve. But before we go ahead and solve, we kind of can see that this 9 and this 18 both have a factor of a whole 9 in it. So 18 divided by 9 is equal to 2. 9 divided by 9 is 1. So now we can go ahead and multiply the top numbers together, and then we can multiply the bottom numbers together. So we get 2 times 2, which is equal to 4, and 1 times 1, which is equal to 1. So we could leave this as 4 over 1, or we could just go ahead and say 4. So we'd have 4 whole pieces. Now let's do another example. An 8-foot sheet metal is cut into pieces that are 4 7/8 inches long. How many pieces can one get if we disregard the curve? So we're going to use the expression below. We have 96 divided by the improper fraction of this mixed number, which is 39 over 8. So now when we go ahead and now we can make this a new problem. So we can go ahead and put this 96, we'll put it over 1 to make it a fraction. And then instead of dividing, we're going to go ahead and multiply, and we're going to take the reciprocal of the second one so we can do that. So now we have our problem all now set up. So now we have 96 times 8, and then we have 1 times 39. Now we see that 96 and 39 can actually be divided by 3. So 3 can go into 96 how many times? Well, 3 can go into 9 3 times, and then 3 can go into 6 2 times. So now this is 32. And now we have 39 divided by 3. So 3 can go into 3 1 time, and then 3 can go into 9 3 times. So we divided this number and this number by 3, and we got 2 new numbers. So now it's reduced, and we can go ahead and multiply now. So we have 32 times 8. So let's go ahead and do that over the side. We have 32 times 8. 2 times 8 is 16. 6 below, carry the 1. 3 times 8 is 24. Plus 1 is 25. So we get 256 divided by 1 times 13 now. So that's just 13. And then that would be our solution if we stop there. But we're going to see how many pieces we can get if we were to take this 8-foot sheet metal and divide it into pieces that are 4 7/8 inches long. So we need to see how many whole pieces we can get. So now what we do is we take 256, we're going to go ahead and just divide it by 13 as our fraction bar represents division. So we can see how many whole pieces there are. So we have 256. 13 can go into 25 1 time. So we will leave a 13 there. Now we have 25 minus 13. So 5 minus 3 is 2. 2 minus 1 is 1. Then we go ahead and bring down this 6. Now 13 can go into 126 how many times? Well, if we did 13 times 10, as any time we do a multiple of 10 times a number, we just add the number and add a 0. So that'd be 130. So let's go 13 then times 9, because 126 is less than 130. So 3 times 9 is 27. Put the 7 below, carry the 2. 9 times 1 is 9, plus 2 is 11. So we have 117. So if we put 9 right there, so we have 19 now. 13 times this 9 is 117. We go ahead and subtract. We have to borrow. So 16 minus 7, which is 9. Now, we have 19 whole pieces and a remainder left over. So if we're going to say how many whole pieces there are, we're going to say there's going to be 19 whole pieces.